The 2002 National Electrical Code, commonly referred to as the NEC, does not contain explicit requirements mandating that temporary power poles must conform to the entirety of Article 230. Article 230 of the NEC addresses service entrances, which are the conductors and equipment used to deliver electricity from the serving utility to the premises wiring system. While temporary power installations, including those utilizing temporary poles, must adhere to certain safety standards and code requirements, the NEC doesn't universally mandate full compliance with Article 230 for temporary setups in the 2002 edition. The rationale behind this is that temporary installations, by their very nature, are intended to be short-term and are subject to different considerations than permanent service entrances. However, it is important to clarify that this doesn't imply a complete absence of regulation or safety measures for temporary power poles. The NEC addresses temporary installations in Article 590, which specifically covers the requirements for temporary electrical power and lighting installations. This article provides guidelines and regulations designed to ensure safety during the temporary use of electricity for purposes such as construction, maintenance, repair, or demolition of buildings or structures, as well as for other similar activities. Article 590 mandates that temporary electrical power and lighting installations must be installed in a manner that prevents hazards to people and property. This includes ensuring proper grounding, overcurrent protection, and the use of suitable wiring methods. The specific requirements for temporary installations may vary depending on the duration of the installation, the voltage levels involved, and the specific environment in which the installation is located. For example, temporary wiring used in damp or wet locations must be of a type approved for such conditions. Furthermore, all temporary electrical equipment, including extension cords, portable tools, and lighting fixtures, must be properly grounded or double insulated to prevent electrical shock hazards. Ground fault circuit interrupters, or GFCIs, are often required for temporary circuits to provide additional protection against electrical shock, particularly in areas where there is a high risk of contact with water or conductive materials. Local jurisdictions and authorities having jurisdiction, OJs, may also have their own specific requirements for temporary electrical installations. These local regulations may be more stringent than the NEC requirements and may address specific conditions or concerns unique to the area. It is therefore crucial to consult with a local AHA to determine the applicable requirements for temporary power poles and other temporary electrical installations in a given location. In summary, while the 2002 NEC doesn't mandate that temporary power poles must strictly adhere to Article 230, it does require compliance with Article 590 and other relevant sections of the Code. These provisions are designed to ensure the safety of temporary electrical installations and to minimize the risk of electrical hazards. The key to ensuring a safe and compliant temporary power installation is to carefully assess the specific requirements of the project, consult with the local AHA, and follow all applicable codes and standards. This includes selecting appropriate wiring methods, providing adequate overcurrent protection, ensuring proper grounding, and using GFCIs where required. By taking these steps, it is possible to safely and effectively utilize temporary power poles and other temporary electrical equipment for a wide range of applications. Understanding the specific requirements outlined in Article 590 is critical for anyone involved in the design, installation, or maintenance of temporary electrical systems. This article covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and the use of ground fault circuit interrupters. It also addresses the specific requirements for temporary lighting, receptacles, and other electrical equipment. One of the key requirements of Article 590 is that all temporary wiring must be protected from physical damage. This can be achieved through the use of raceways, such as conduit or cable trays, or by using cables that are specifically designed for direct burial or exposure to the elements. The wiring must also be securely supported and properly terminated to prevent loose connections or other hazards. Overcurrent protection is another critical aspect of temporary electrical installations. Article 590 requires that all temporary circuits be protected by fuses or circuit breakers that are properly sized to protect the wiring and equipment connected to the circuit. The overcurrent protection devices must be readily accessible and clearly labeled to indicate the circuit they protect. Grounding is essential for preventing electrical shock hazards in temporary electrical systems. Article 590 requires that all metal enclosures and non-current carrying metal parts of electrical equipment be properly grounded. This can be achieved by connecting the equipment to a grounding electrode system, such as a ground rod or a metal water pipe. Ground fault circuit interrupters, or GFCIs, are required for many temporary circuits to provide additional protection against electrical shock. GFCIs are designed to detect even small amounts of current leakage to ground and to quickly de-energize the circuit, preventing a potentially fatal electrical shock. Article 590 specifies the locations where GFCIs are required, such as in damp or wet locations, and for receptacles that serve construction sites or other hazardous environments. In addition to the general requirements for temporary electrical installations, Article 590 also includes specific provisions for temporary lighting. Temporary lighting must be installed in a manner that prevents hazards to people and property. This includes ensuring that the lighting fixtures are properly supported, that the wiring is protected from physical damage, and that the lighting is not obstructed by materials or equipment. The use of temporary power poles can be a convenient and cost-effective way to provide electrical power to temporary locations. However, it is important to ensure that the poles are installed safely and in accordance with all applicable codes and standards. This includes selecting poles that are of adequate strength and stability, ensuring that the poles are properly grounded, and providing adequate clearance from overhead power lines or other obstructions. It is also important to regularly inspect temporary power poles and other temporary electrical equipment to ensure that they are in good condition and that they are not creating any safety hazards. Any damaged or defective equipment should be repaired or replaced immediately. By following these guidelines and consulting with qualified electrical professionals, it is possible to safely and effectively utilize temporary power poles and other temporary electrical equipment for a wide range of applications. It is also worth noting that the NEC is updated on a regular basis, typically every 3 years. Therefore, it is important to stay up to date with the latest edition of the code and to be aware of any changes or revisions that may affect temporary electrical installations. The NEC is a comprehensive document that covers a wide range of electrical safety topics. It is essential for anyone involved in the design, installation, or maintenance of electrical systems to have a thorough understanding of the NEC requirements. This includes understanding the general requirements for electrical installations, as well as the specific requirements for temporary installations, hazardous locations, and other specialized applications. In addition to the NEC, there are also a number of other codes and standards that may apply to temporary electrical installations. These include local building codes, fire codes, and OSHA regulations. It is important to consult with the local AHA to determine the applicable requirements for a given project. The use of qualified electrical professionals is essential for ensuring the safety and compliance of temporary electrical installations. Electrical contractors, electricians, and electrical engineers have the knowledge and experience to design, install, and maintain electrical systems in accordance with all applicable codes and standards. They can also provide valuable guidance on selecting the appropriate equipment and materials for a given application. When selecting an electrical contractor or electrician, it is important to choose someone who is licensed and insured. This will help to ensure that the work is performed safely and to code, and that you are protected in the event of an accident or injury. It is also important to ask for references and to check the contractor's or electrician's track record before hiring them. A reputable electrical contractor or electrician will be happy to provide you with references and to answer any questions you may have. In conclusion, while the 2002 NEC does not explicitly require temporary power poles to conform to Article 230, it does require compliance with Article 590 and other relevant sections of the code. These provisions are designed to ensure the safety of temporary electrical installations and to minimize the risk of electrical hazards. The key to ensuring a safe and compliant temporary power installation is to carefully assess the specific requirements of the project, consult with the local AHJ, and follow all applicable codes and standards. This includes selecting appropriate wiring methods, providing adequate overcurrent protection, ensuring proper grounding, and using GFCIs where required. The NEC also addresses GFCI protection extensively. Ground fault circuit interrupters are crucial safety devices designed to protect individuals from electrical shock. They work by monitoring the current flowing through a circuit and quickly interrupting the power if they detect a difference between the outgoing and incoming current, indicating a potential ground fault. In temporary installations, GFCIs are particularly important due to the increased risk of exposure to wet or damp conditions and the potential for damage to equipment. Article 590 of the NEC mandates the use of GFCIs in various temporary setups. This includes temporary wiring used in damp or wet locations, as well as for receptacles that are readily accessible to personnel. The specific requirements for GFCI protection may vary depending on the type of installation and the environment in which it is located. For example, GFCIs are typically required for all 125 volt, 15 amp and 20 amp receptacles used on construction sites. These receptacles are often used to power portable tools and equipment, which can be subject to damage or misuse, increasing the risk of electrical shock. In addition to receptacles, GFCIs may also be required for temporary lighting circuits, especially those used in damp or wet locations. Temporary lighting is often exposed to the elements and can be easily damaged, making it more likely to develop a ground fault. GFCIs provide an extra layer of protection in these situations, helping to prevent electrical shocks and injuries. When selecting GFCIs for temporary installations, it is important to choose devices that are specifically designed for outdoor use. These GFCIs are typically housed in weather-resistant enclosures and are designed to withstand the rigors of construction sites and other outdoor environments. It is also important to ensure that the GFCIs are properly installed and tested before use. GFCIs should be tested regularly to verify that they are functioning correctly. This can be done using a GFCI tester, which is a simple device that simulates a ground fault and verifies that the GFCI trips properly. If a GFCI fails to trip when tested, it should be replaced immediately. In addition to GFCIs, other safety measures should also be taken to protect against electrical hazards in temporary installations. This includes using properly grounded equipment, inspecting cords and cables for damage, and avoiding the use of extension cords whenever possible. Extension cords should only be used as a temporary solution and should never be used to create a permanent wiring system. When using extension cords, it is important to choose cords that are of the proper gauge and length for the application. Undersized or overloaded extension cords can overheat and cause a fire. It is also important to protect extension cords from damage by running them through conduit or cable trays. Regular inspections of temporary electrical installations are essential for identifying and correcting potential hazards. Inspections should be performed by qualified electrical personnel and should include a visual inspection of all wiring, equipment, and safety devices. Any damaged or defective equipment should be repaired or replaced immediately. In addition to visual inspections, electrical testing should also be performed to verify the integrity of the grounding system and to identify any potential ground faults. Testing should be performed using calibrated test equipment and should be documented in a written report. The documentation should include the date of the inspection, the name of the inspector, and a list of any deficiencies that were identified. The deficiencies should be corrected as soon as possible and the corrections should be documented in the report. By following these safety guidelines, it is possible to minimize the risk of electrical hazards in temporary installations and to protect workers and the public from electrical shock and injuries. Remember that electrical safety is everyone's responsibility. If you see something that doesn't look right, report it to a qualified electrical professional immediately. Also, ensure you understand lockout-tagout procedures to de-energize and safely service electrical equipment. Always verify circuits are de-energized with a meter before working on them. Maintain proper clearances around electrical panels and equipment. Never block access to electrical panels or equipment. Use appropriate personal protective equipment, PPE such as gloves, safety glasses, and arc-rated clothing when working on or near electrical equipment. Be aware of the potential for arc flash and arc blast hazards and take steps to mitigate these risks. Follow safe work practices and procedures at all times. Attend regular safety training sessions to stay up to date on the latest safety requirements and procedures. By following these guidelines, you can help to create a safe work environment and prevent electrical accidents and injuries. Remember, electrical safety is not just a matter of compliance, it's a matter of life and death.